Bismillahirrahmanirrahim. Today we are looking into the second chapter. Second chapter is Vienna development method. Okay, for Vienna development method, okay, we have probably we are seeing a lot of modeling. Modeling. Okay, we seen a lot of modeling. Basically to model to model the development of computer-based system. Okay. Okay, and then a little bit of history. This one is originating from IBM laboratory, Vienna in 1970, in the late 1970. Okay, and then it has an extended version. Okay, we have VDM++, which support the modeling of object-oriented and concurrent system. Okay, and then we have also we have the uh, VDM include the commercial and academic tools. Okay, and then for this one, for Vienna development method, is basically is model based method. Model based method. Okay, and then this one is to formalize, uh, formalize the research in formalism. Uh, has lead notably in contribution of critical system compiler. Okay, basically for logic, for computer science. Okay, and then for VDM, we are introducing to you guys. We have VDM and VDM-SL. Okay, VDM is basically formal, mathematically oriented. This one is basically based on the mathematical oriented. Basically based on the mathematical oriented for specification system and development, specifically for specification system and development and development. Okay. Okay, if you look into the definition, definition of VDM, VDM is a collection of techniques. Okay, collection of technique. Uh, collection of techniques for modeling, specification, and design. Basically for computer-based system. Is dependable on the mathematical approach. Uh, in order to model, we need the formal specification that I explained last week. Last week for formal specification. Okay, and then okay. Do you have any question? Ada soalan ke? Do you have any question? Ada soalan ke, Afika? Boleh ke? Boleh, Afika? Okay. Okay, and then okay, for the history. Okay, we have late 70, this one I explained, and then we have VDM-SL, specification language, and VDM++. And then we have VDM++ is object-oriented approach, VDM++. And then this one, we want to derive the model because we want to model a base method. This one is based on the model-based method. And for deriving the model, and then later on we seen an example for modeling the VDM. Okay, and then VDM is basically when you talk about VDM, it's about the testing and proving the properties. This one is the main or uh, the main problem for the VDM is to modeling for testing and proving the properties. Okay, and then we have the tools for VDM, Vienna development method. We have our virtual tools. Okay, for the VDM, we have tools. Tools, namely as a virtual tool, TURE. Okay, TURE, a virtual tool. Okay. Okay. Other than that, we have also API like Cobra. Okay, and then we have document generator. Okay, and then we have Rose VDM plus plus link, and then we have Java or C plus plus code generator. This one is the tools, VDM tools. Okay. Other than that, we have interpreter, interpreter. Other than that, we have API like Corba. Okay, this one is a tool, VDM tools. And then other than that, we have a document generator. Okay. Okay. For VDM, it have a simple syntax and semantic that using the ISO standard. This one is common. If you talk about the interpreter, it must have the standard. Standard mean that it has it have the ISO defined interchange syntax is used, or the other one is we name it as SKey. And then some tags prefer a more concurrent. Basically, we do in mathematical syntax. And then for VDM-SL, model is system description given in terms of functionality perform on data. It consists of series of definition of data, types and function or operation performed upon them. And then they have a syntax here. If you see, there are names in our model. I was speaking with the capital letter. This one for the general syntax. And then we have function names that always begin with a capital letter. And then we have formal parameters and object. Okay, formal parameters and object are always in the lowercase. Okay, and then the last one, all function specific to INS. Okay, INS are referring to have the ending INS mean instruction. Okay, and then similarly, names of EC specific function end in ET at EC. Lah. Okay, this one is the some of the overview. Okay. Okay, we have okay, INS. Okay, INS stand for initial navigation system. EC mean external computer. Okay. Boleh? Ada soalan ke? Akila? Nur Akila okey? Nur Akila? Okay. Okay, jangan tidur eh. Okay, and then this one is syntax and semantic. VDM-SL, specification language, and VDM++ based on object-oriented uh, has several syntax and semantics. Okay, and then this one is to apply the further extent by the use of VDM by applying within new domain or new problems. Okay, and then we have ISO standards that defined in the ASCII syntax. Okay, and then VDM-SL basically is more on the functionalities on data. Okay, it is basically a system description given in terms of functionality performed on the data. Okay, this one is technically is very common. Okay, and then okay, so far do you have any question? Okay, for communication protocols in VDM, in VDM. Okay, I will explain to you. This one we have initial navigational system and EC external computer. We don't look into details. Okay, VDM is basically is a formal mathematically oriented method for specification system and development of the software. Okay, and then okay, when you want to use the VDM, new slide. Okay, when you want to use the VDM, they have several requirements that you need to understand. Okay, when you are using VDM, okay, this one is VDM. Abstract model traditionally contain the following component. We have a component. Okay, can you read my handwritten? Boleh baca ke? First one is we call it as semantic domain. Okay, this one is the type that define the object to operated on. This one we define the types. Okay, and then number two, we should have invariant. Invariant basically functions that limit the set. Function that limit the set of object. Okay, defined by semantic domain. defined by domain. Example here we have Boolean, Boolean expression. Boleh baca ke ni? Can you read this one? Boleh. And then number three, we should have the syntactic domain. Tactic, tactic domain. Okay. Okay, this one is a type that define the language with express command for manipulating the object defined by semantic domains. Okay, this one is syntactic. Okay, defined by semantic domain. Okay, and then number four, we should have well-formed condition. Well-formed condition. This one is basically a function that define commands that are defined by syntactic domain have a well-defined effect. Have a well-defined effect. Okay, and then lastly, number five, we have a semantic function. A function that define the effect of command on the object defined by semantic domain. This one is effects of command. Okay, boleh boleh baca Sorry tak cantik tulisan ni. Tulisan saya boleh baca je. Okay, okay, thank you. This one is components that defining the syntax by using the semantic domains. Okay, we have first we have semantic domain, and then we have invariant. Basically, invariant is the function that limit. Okay, and then we have syntactic domain, well-formedness condition, and lastly is semantic functions. Okay, this one VDM-SL model. We have a system description that given by the terms of the functionality that perform on data. This one perform on data. Okay, okay system functionalities on data. Okay, we have a Boolean data type. We have natural number excluding zero, natural number, and natural number excluding including zero. And then we have natural number excluding zero and one. Okay, this one is a symbol of okay. Natural number with zero and then natural number. Okay, this one is data type. Basically, when you talk about data types, we want to have the functionalities. Okay, to model the environment. Okay, first one data type being defined to represent the main data of the model system. Okay, each type definition will be introduces a new data type and give some simple representation in terms of basic type, in terms of data types already being introduced. For example, we have types user ID is equal to NAT. NAT is natural numbers, including zeros. Including zeros, the the member 1, 2, 3, 4, 5, and so on. And then what is invariant? Invariant is a complex expression that has membership. Okay, for satisfying the invariant, and then we add some complexity. This one is for example, we have a char is equivalent to character. Okay, this one for the invariant. Okay, do you have any question? You know, ada soalan ke? Okay, invariant quite literally means something that do not does not change or vary. In the context of computer programming, basically it can be defined or seen as a set of assumptions, uh, a piece of code that takes before it is able to perform any computational or important fees. Okay, by adding some complexity lah. This one is invariant, or in VDM we can say that it has a complex expression that include the membership that satisfying the invariant condition. Okay, example of invariance we express in basically in mathematics. Mathematics for invariant we have a finite set lah. Finite set mean that you can count. Finite set. Okay, example. This one is for example. Okay, and then okay, this one is a basic data type. Okay, you can have a numeric, character, token, and code types. Okay, code types. This one is the uh, operators that that have equality and inequality. Okay, and then language also does not fit the maximum or minimum representable number. Okay, this one is we not defining the values, and we are denoting the condition only. Okay, this one is a basic data type, but here in VDM, we're not looking for the values. We are looking for the condition only. This one is the interpretation that used in describing the certain algorithms. Okay. Okay, and then okay, for equality and equality, we have some of the set of the object that based on the constructor that define the set in n elements, and then we have a set membership, we have a subset relation, and so on. Okay, do you have any question? Ada soalan ke? Okay, boleh setakat ni boleh ikut. Boleh. Okay, thank you. Kalau boleh, boleh kita teruskan ke? Okay, inequality or equality in mathematics, right? Basically, if you use mathematics, you can have a symbol like this. You have a greater than, less than, equal to, okay, uh, less than or equal to, greater than or equal to. This one is equality and equality and inequality. Okay, a requirement that user identifier must be no greater than 9,999 would be written or expressed as follows. We have inequality and equality here. Okay, uh, this one is a Boolean operator on natural numbers. And then since invariant can be arbitrarily complex logic expression, and membership is defined is limited to only for those values that satisfying the invariant. The type of correctness in VDM-SL is not automatically defined or decidable in all situations. This one is including the uh, members of the complexities. Okay, for example, here we can have the structureless token. Okay, the structureless token. Okay, and then the value of the token itself may be represented as no operators. No operators. Okay, this one is basically structureless for VDM. Is basically is defined by the token. Defined by the token. And then we have a specific name. Specific name required to define the codes. Okay, the codes that we are having here. We have the code that containing the values here. Okay, for example, we have modeling a traffic signal controller. This one is the controller that is a very complex system that required a virtual tools to express the type, function, and also the expression. Okay, this one we have red, amber, flashing amber, and green. What is amber colors? Amber color is between orange and red. This one is amber. We name it and we recognize as amber. Okay, and then for structuring based on the ISO standard, we have a structuring principle. And first one, we should have the naming, module naming. Module naming. Okay, for the VDM module naming, each module is syntactically started with the keyword module followed by the name of the module. Okay, because of what? Because each module is syntactically started with the keyword uh, to avoiding the ambiguity of the system. Okay, the ambiguity. Okay, and then followed by again by the name of the module. Later we see this one. And then to import and to export, we are using the different modules. For example, here to import the signature for specific type, values and function and operation, and each these are started with the corresponding keyword. We started with the corresponding keyword. In addition, this import signature name that construct the desire to access. Okay, for example, if we have the struct A, you want to access the membership of A, you need to import the signature from struct A to access the members of A. This one is similarly to object oriented. We have the privileges. Later we see this one. Okay, then for exporting also same. We have to export another module to different module by using the keyword export. And then this export signature specific for certain data type. Okay, we have a certain data type. In some of the cases, we need to have the internal structure and type the keyword struct must be used. Okay, this one if you look for the VDM tools syntax in details, you can find out uh, the standard of the VDM plus plus uh, have the instant variable for VDM-SL. This one is basically is a structured approach. They are using they are using they are using non-instant variable access. Okay, so far do you have any question? Ada soalan ke? Okay, later we see this one in details. Okay, we have binding. This one is basically in a virtual format. This software. Okay, and then for VDM-SL, we have some of the types. We have type, and then we type on the some types, and then we have values. Okay, and then we have a constant name followed by constant type, and then give some values, and then we state the system name. Okay, okay in VDM. VDM plus plus this one for the VDM SL. For VDM plus plus, object can be passive and active. And then in VDM plus plus, we can use concurrency in specification because of the passive and active approach. Okay, okay we goes for the VDM plus plus. This one is based on the classes. Okay, when you talk about the classes or object oriented, it can be uh, reuse because of what? Because it using classes and multiple inheritance. And then in VDM plus plus, we have classes here. We have classes, we have inheritance, and then we have access modifiers. Okay, for functional modeling in VDM-SL, a function are defined over the data type defined in a model because it is a structured approach. Support for abstraction requires it should be possible to characterize the result based on the output or membership of the invariant that I have been described before. That the function should compute without having to say how it should be computed. This one we define and we evaluate not the values, uh, the values of the segment, but we define the operation, the argument. Okay. Okay, and then the main mechanism for doing this to see the formula computing a result, we have the pre and post condition for the modeling. We should have the post pre and post condition. Okay. Okay, VDM-SL, we need to have the operational header. First one. Secondly, we should have the external clauses, precondition and postcondition. Okay, for this one, okay, this one is the operational header. This one is the header. Okay, this one is the header. Okay, and then we have a function square root for calculating the square root of a natural number might be defined as follows. Lah. Okay, and then for functional modeling, we have a post condition that does not define a method for calculating that uh, state the properties also. This one is we compute the properties, not the values. Like I said before, it hold the properties for this one. Okay, and computed properties. Hmm? It's not computed the value because of what? Because of the approach. For functional modeling in VDM-SL, we are looking into the uh, uh, functional. Okay. Okay, and then okay, uh, okay, and then the specification would be satisfied if, for example, by function that return the negative root of 4, but the positive root of all other invalid input. Note that function within SL are required to be deterministic. So that the function satisfying the example specification above must always return the same result for the same input, returning the same values. Okay. Okay. What is deterministic? Deterministic is the model that allow you to calculate the prediction of the model. The prediction of the model. This one is the example of deterministic model. For example, we have the conversion between Celsius and Kelvin. Okay, deterministic example. We have the uh, conversion between Celsius and Kelvin. Okay, the return the values, returning the same values. Okay, then for the state-based modeling in VDM-SL, we have a useful ability in many programming languages that that embed the function operation used to change the state of the variable, also known as a global variable. If you have the global variable, that you can embed any functions or operation that outside the uh, outside the global definition. For example, if we have the state register of some state register is equivalent to natural number, this one we have consisting of single variable. Okay, this one we including just a single variable, okay, namely as a some state register. In VDM++, this should be instead be defined as instant variable because this one is basically uh, in object-oriented operation or OP operation. Okay, for the summary, VDM is a large language, very complicated languages that constructed many forms of models, uh, many form of model, and basically for the VDM++, the approach is using the uh, general purpose programming languages like Java and C++. And then we must remember, however, the intent of VDM is not to program, but to specify a model of the program. This one is the first I have told to you. VDM is based on the model based on the method. And then the level of abstraction is necessarily higher than the general purpose languages. We can specify model using high level construct such as set. We have map here, and then we have implicit function, and then without having to worry about the how they will be implemented. This one we are looking just for the structure, structure, structuring, structuring process. Because of what? Because we want to model in SDLC, software development life cycle. Okay, this one we are using a lot. We are using semantic a lot because it involving the set, map, implicit function. Okay, this one is very logically mathematical driven. Okay, and then this one is example for the VDM-SL. We have incubator monitoring system. Okay, incubator monitoring system and will record the increment, record the decrement, and read the value of the temperature. This one is incubator monitoring system. Okay, and then we record the increment, record the decrement, and then read the value of the temperature. And then this one we need to specify the function by using the VDM++. Later next week we are looking Z notation. Z notation. Okay, and then this one I have explained VDM-SL. Okay, so far do you have any questions? Okay, so far we are have looked VDM-SL and VDM++. Ada soalan ke? Boleh eh? Simple je. Okay, please be reminded after this you need to upload your own notes using any kind of software. Basically, you can type upon in words, you can type uh, in any format, and then please upload to Bandlet. This one is for your own benefit. Some of you We'll refer this one if they are in a need. For example, if final assessment is quite near, you can refer back at the Padlet.